Okay, here we are. So first of all, a little disclaimer, I hate hand mics, and I will probably very often use it incorrectly, so please let me know if you cannot hear anything or something. Like René said, I will be talking about content duplication. And before we start, let me introduce myself. My name is Zbyszko, and I lead the search team at Brainly. And I will not tell you anything more about me because there's no time. So let's get back to the title. I have to admit, I did deceive you a bit when it comes to the title. The actual one I wanted to use, but I was asked not to. It looks like this. It's kind of rolls of the tongue, right? It's an educational user-generated content duplication at Brainly. So why I'm doing this, it's actually important, so let's dive into the title and see what it means. First of all, what does it mean at Brainly? Brainly helps students all around the world get help to the places, get help with exercises, questions, tasks they have to perform do for school, and that's basically a community platform. Learners help each other proceed. They can ask questions. Those questions will be answered by somebody from the community, and it usually happens very quickly. But they can also find those questions. Any questions that were asked, they are available in our database. You can search for them, and that's how it basically looks like. So why I'm talking right now about content duplication? First of all, I will show a few reasons why we want to do this. They might be relevant to you. First of all, obviously, when it comes to user experience, it's a somewhat terrible thing. I mean, as you can see in Brainly, we have the maximum number you'll see of answers here are 2. So that's how much we allow for each. So the maximal number of answers you will see here is 2, and that's by design on Brainly. Which means if you have duplicates, you are leaving this to user to basically find the right answer of all of those. And believe me, we don't have like 5 answers to that questions. We have more closer to like 500 probably or something like this. This is unfortunately quite a problem, and we are looking into ways of deduplicating at the input level, but that is what we have right now, quite often. Second of all, I mentioned those answers, and learners coming to Brainly don't really look for questions, they look for answers. So the relevancy of the answer is what we are striving at. And because we have those aggregates of maximum 2 answers per question, we sort of make it difficult to find. So, and the third point is very important for us, is that duplicates tend to hide insight. For example, that's a temperature map taken somewhere. You can imagine that temperature is being measured at a few different places in Poland. They obviously have a different weather patterns in general. For example, it's usually across the year, it's usually hotter in Kraków than it is in Gdańsk. But if you have for example, more weather stations in Gdańsk than in Kraków, and you don't know about this, you will get different results here because you will not be able to make guessed decisions about the mean temperature represented by all the stations. And that's a reason for duplication. We can duplicate easily based on the geographical location here, right? And that's the same thing in our case. We want to get more insight out of our data, the engagement insight, and so on. Okay, so let's talk a bit what does user-generated means. First of all, let's meet the user. That's our user. There are more of them than this one, obviously. So our users are usually, like most cases, are in high school, in primary schools, and so on. Bless their hearts, they do not know how to write proper grammatical questions quite often, and they use various amounts of additional words that don't really need to be there. Like, for example, this here. Also, so I had to blur this, but you can guess from the quality here how it looks like. super easy to duplicate or even like analyze or something. Or they can input very, very long questions into the database. By the way, those are the documents from our database, but they are quite often also the queries we get. So we tend to get multi-line queries, which is somewhat unusual for your standard search, but that's what we have to deal with in general. Okay, so what does educational mean? Educational content is difficult to process for us, or generally. It's diverse in the meaning that you will get subjects like mathematical questions, biological, geographical, historical, you name it. And multiply this by different ways. All of those subjects are being taught in different countries. You have like a lot of different subjects, and even the same question can have a different answers depending on the grade where the student is in. So, for example, you will answer differently for a first year student than you will answer for like 8th year student, right? So that's diversity, and there are very important differences between those two questions. And since learners come here to get a very specific help for a very specific question, it's important to get them right. And the sort of most difficult part of all of this is math. So math is apparently the most difficult subject for at least US, if I remember correctly. Like the largest subject there is actually mathematical. And analyzing mathematical questions is difficult because those things contain the same tokens, basically, if you do a standard tokenization, which means that, and there are obviously very different problems to solve. So, and we have to know this, we have to understand this. So that's the issues we have. We knew early on what we need to duplicate the content we already have. We have a huge amount of data, which very valuable answers, and the idea was to, the reason I'm speaking at this particular place, which is about search, is that we sort of treat the duplication as a search problem. So all the things I just mentioned, those are, the duplication here is basically finding exact matches. What does an exact match mean? That's up for debate, and we actually change the definition at some point. But we can tell this all about this later on. So first of all, let's talk about vector versus keywords approach we took to find those duplicates in our data set. We started with vectors. I think that was because in Brainy there were a lot more machine learning engineers than there were search engineers, so obviously, hammer nail situation. But vectors make sense because, the long queries and so on. Like Etta said, vectors actually might be better for that kind of content. So it made sense to start with something like this. By the way, so I have to warn you, I use memes in my presentations. I started recently, so they're very unfunny. I hope it will not distract you. I also like colors, so there will be a lot of colors. So, okay, first approach we had with vector search, vector deduplication. That was quite easy. We just started with some pre-selected content of curated questions. Basically, the idea is to go through this content, through this data set we selected, and find for each of those, find all the duplicates we can find. You can easily find something like this in your case, like have most popular questions, for example, and get those, or even have somebody create the content for you, which happened for us, based on some curriculum data. What we then did was basically do a complete one-to-one cosine similarity calculations. I'm not sure if I mentioned this, but I think she did. In vectors, generally, what we get is some kind of a similarity. It's a similarity calculated in vector space, and quite often one use is cosine similarity. So that's what we used here. We didn't use anything, any kind of database, any kind of search. We just did a Python script that calculated all of those. We selected 0.9 matches. The biggest one is 1, so that's more. You can think about it as 90%. That's not really precisely what that, but it's a good intuition. And we got our results. So I will show two numbers on this. So first there's recall and precision. I'm assuming most of you know what recall and precision is. Who knows what recall and precision is? Okay, so a quick explanation for folks who don't know this. Precision is a measure of how many relevant results were returned to the user. So in our case, how many of the found duplicates were actually duplicates of the question we were analyzing. And the recall is a measure of providing how many of the actual duplicates from the data set we did manage to get in the query we're doing. And that's basically a value between 0 and 1. And we did strive for precision, but we didn't want to get too low of a recall. So our precision was quite good at 800%, sorry, closer to 900%, 900. And recall was, as you can see, 0.400. Not the results for the first try, but obviously there were some issues with the. Oh, that's broken. Sorry, I was supposed to do it differently. First of all, it was super slow. I mean, you can imagine like calculating. There's like dozens of questions, so generating text embeddings for them, then which need to happen, but then actually calculating each one of those, it took forever. And because of all of this, it's also quite computationally expensive. And results honestly could be better. So my original idea for this talk was to present you with all the approaches we took, but that would take at least 2 hours, so I decided not to do that. Instead, I will go with this. I will tell you what we did in the meantime, what things we did. First of all, when we started a very basic BERT model that we could basically get off the shelf. Off the shelf, I obviously mean open source. And we decided to change that, so we trained our own model based on the available ones and the data we have in Brainly, which made sense for us since that's not exactly how the general models work. There are also existing models that allow you to that are focused on the duplication. For example, Quora has one that's very interesting. I would recommend looking into that. But we tried many of those, like 2 dozens at least, or something around that number. Many retrainings, many testing the theories. We also did some data processing, since we found out that it actually helps to, especially with maths, to start with some processing first. And we decided that the approach of doing a manual one-to-one calculation was not very good, so we use a Feist index. That's sort of similar to what Elasticsearch has now with hierarchical navigable small world graphs. To make this quicker. So that's our second approach. By second, I mean probably 100th approach. So we trained the model, created the index, again used the same data set, and searched this in a Feist index. Obviously, that was much faster than the previous approach. Again, selected the same matches and got our results. And what are the results? On our labeled data set, we got improvement, more or less. Precision didn't budge much, and it shouldn't actually, because Feist, what it does, Feist actually shouldn't provide better results than one-to-one cosine similar calculations. It's sort of an approximate algorithm, so it helps with making things faster, less computationally expensive, but it will not make results better. But other things we tried did at least allowed us to precision to stay basically the same. But what did change is that recall spiked like 25% or something, which is better, obviously. I again broken my animation. Here we go. First of all, it's better. It's not great, but it's better. The main issue we had in general with all of this is that it takes a lot of time and a lot of money. And I will have numbers to back it up, but generally it doesn't really help. It's not easy to experiment with something, try something new, because it all takes like a long time and costs a lot of money. And also we decided to stop with that for a few weeks and reevaluate our approach. So we did stop. And I will leave this slide for the last of the presentation, sorry for that. Somebody in the company, very smart person, decided to think, what is the type of content we actually have in the database? Like, we know that our user-generated, I already said that, right? So it's based on education, it's user-generated, and they are mostly long queries, so, you know, it all fit. But how this content is actually created, that's another question. Next slide, I will show you the most popular query in web search. I'm not sure if you should have signed the NDA before that, so I asked my lead who's sitting there to make sure that's okay. So the top question, the top query we have on web search is this one. It's a single letter V. Can somebody tell me why? Exactly. And that's the thing. It is user-generated, but it also is it's also based on the curriculum. So in many, many situations, we will get the questions that will be either identical or very, very similar to what users have in their textbooks, exams, and so on. So, like the photo you've seen before, that was basically a photo screen of some quiz and so on. By the way, we don't allow cheating on Brain. There's a code of honor or something on our page. So that's the most popular question. People are copying content constantly, and actually, first one is lowercase v, and the second one is uppercase v. So I'm guessing one is because somebody forgot to push command or control. Second one is because they confused it with shift. Like I said, those are our users. Those are learners who want to know answers. I'll help them through some difficult mathematical, for example, questions and so on. So the content actually comes from a very specific source. And even if the questions are very, very long, it doesn't mean that exact matching wouldn't help. So we decided to try something else. We decided to go with Elasticsearch. We started with Elasticsearch, but then we switched to OpenSearch because we use AWS. Made sense to make the switch at some point. So what we did is we created an OpenSearch index out of all our questions. It was a more or less a normal index. We didn't really do much work on it other than providing some sane defaults when it comes to stop words, some additional fields, maybe some light boosting. Nothing complicated. Seriously, it's like maybe 2 days job. We did prepare a strict strategy. And by strict, I mean that the idea was to find the exact matches, and we assumed that in most cases we will get exact matches. We did come up with a sort of hacky way to have a scoring that you could normalize. BM25 is obviously not, you cannot normalize BM25. We did something else. We manipulated BM25 to some degree. That's because I was working with machine learning engineers. They need to have thresholds, so I provided them with thresholds. And I was very angry I had to do this, but I did. Apparently, that was actually a good idea at some point. So again, the same target content to duplicate. We basically search all the questions through the OpenSearch index and got our results. And results. Oh, now you're animating. That's interesting. Okay, here you are. I don't know what happened. So those are the results. And the fun part is they actually are better than our best effort for machine learning, using machine learning and a vector approach. That wasn't even a goal, and this is only some values I've selected that had the biggest F1 combines recall and precision. But if we wanted to go more towards the precision, we could easily do that. If we wanted to go more into recall, we could do that as well. It was very easy to manipulate. And that's the whole point of this. I really enjoy is that having this is much simpler, it requires much less work. I mean, indexing the whole index was like maybe 2 hours or something like this. Checking a new strategy is 15 seconds. So it's all much easier to experiment. We can like have a much quicker turnovers, test 50 theories during the day easily, which would have taken probably better part of a decade when we would be doing this in the previous approach. one thing we didn't account for is that we match incomplete questions this way, which the original model didn't do. By incomplete questions, I mean that the content we use for the duplication is contained in some other question, but there's more content to it. And that happens quite often when users, for example, which they shouldn't because it's in our rules, copy the content that contains more than one, for example, mathematical equation or something, more tasks to a single exercise. And that's actually quite useful for us. So we didn't really mind that. But if we would have wanted to change that, there are ways of doing this. We can do like a reverse search as well. And actually, we're doing something like this for some use cases. Yeah, let's see that again. Okay, so the question at this point we had is, can we get better results with machine learning? And I think, and machine learning experts at the company, I know they may be a bit biased, but I tend to believe them, think that we could actually probably get better results with machine learning, with better models and so on. But it will be extremely expensive. Cost of a single model training was around $100. And if you remember correctly, we did a lot of those, like a lot of those. So it's not 100, it's during the training, it's probably closer to like $2,000, $3,000, $4,000 than that. And a single match run is about $10. That's not much. But it still accumulates to thousands of dollars to get a new version of Matcher out there. Whereas in case of OpenSearch, the cost of hourly cost of training instances is like 50 cents. So in general, if we want to, for example, by training here, obviously I don't mean training, I mean indexing in this case, we could index in 2 hours, so it's $1. And in peak, when we did the whole process of matching questions, it took around, I don't remember the actual hours, but it costs around $30. So that's probably about 3,000 at least. That's about $30. So a bit cheaper. Another aspect that somebody told me about when I was preparing this presentation is that while you can have a DevOps engineer to maintain the Elasticsearch cluster, you don't need a search engineer to do that, but any DevOps will probably do, especially once they go for training. So that's easy. There are not many machine learning ops people yet. It will probably change, especially with the boom on machine learning. So this slide will not stay true to the reality forever, but the things will. That's the way the things are right now. Okay, so I've talked a lot about matching educational content, which might not be super relevant for many of you. So sorry for that. I did warn Piotr that I will be doing that. But I think there are some takeaways for you as well here. First of all, even if you see that your content is mostly long queries that are user type in your search, it's not always the same situation when it comes to those concepts are not equal to each other. One is a Quora-like or Stack Overflow-like questions asked when they do actually are very, very free flow. And you can see that, for example, in educational, but also, for example, quite often in e-commerce, those will be copied from some other place, and they will actually be quite susceptible to exact matches. It's important to also know when to stop. We decided to go with the Elastic Matcher, and we might do some improvements, but we will mostly do them along with some other searchable problems we'll include. In our case, that was enough, and it's cool to have some target you want to achieve and not optimize further, especially that everything has its own cost. And the numbers I showed you before, I think represent this quite well. Many people tend to jump on the vector search bandwagon, which I think vector search is great for many use cases, but you also need to consider it's in many cases much more expensive than your standard old, your grandmother's Elasticsearch. And this is what I want to leave you. Thank you for listening.
First of all, I would like to make sure that I understand the problem. So you actually didn't want your users to see some duplicates in the search results?
There are multiple reasons we've been doing this. That's one of the things. but in that particular project, the insight was the point.
Okay, so I'm just wondering, why didn't you start with using your already existing search engine to do exactly the same experiment in the first place, to have like a strong baseline,
Okay.
and then reevaluate with different approaches?
The simple answer would be I wasn't there. But to put it in more perspective, that's the situation where we basically had more experts in machine learning, and we know. And like I said, the initial first look, it looks like a problem for vector search, right? I mean, for using vectors, because long queries, user generated. So sounds like a match, right? So I don't blame people for trying this out, especially they did actually get to some pretty nice results at some point. It was almost disheartening to work for 3 weeks and beat the best results they had. But we were working together on this, so there's no hard feelings between us. So.
Okay, thank you. There's one more. Zbyszko, I was wondering, did you do any comparison? Did the two approaches find the same kind of duplicates? Would it make sense to combine them?
Answer is, I didn't. Honestly, I'm not sure if anybody did. It's hard to say. They will. I mean, by sheer numbers, they would have to match the same, at least some of the same questions, obviously, because we did a recall over half. So some will be definitely much the same. But for others, we didn't do that test actually.
Any further questions? Oh, there's one or two.
So a quick one, maybe I didn't get that, but you mentioned the case where you had two sentences that look similar, but one is much shorter, which I assume is a subset of the larger question. So which of these did you prefer?
I mean, it depends which one I'm deduplicating, if I'm one or the other. The problem was that those queries require you a very, very strict strategy when it comes to search. And that, as probably many of you know, focusing on precision will damage your recall. So that's one of the classical questions that are actually quite painful for us. But fortunately, like I said, most of our questions are longer than that, and the longer they are, it's easier to get them, even with some leeways when it comes to strategy.
I'm not sure if that will be a question, but I guess I can see your next step in your journey, because you started with machine learning approach. You realize that with open search you can have better results, and pure open search is to some extent better than previous approaches. So now you can try dense vectors types in open search and go back to machine learning journey and see how that can improve, but stick to open search, right?
Actually, the funny thing is we do actually have a vector search engine at Brainy. It was not used for this particular approach. I'm not sure why. I'm guessing maybe that will different. No, the model was a bit different. I know. I haven't been there and I don't know all the details. But I wouldn't discount machine learning for the application just yet. I mean, there might be situations we might find out that some cases work better than the others, and we are open to this. Maybe we'll get like 100% of everything, who knows? But for now, it seems to work for us quite well, but we'll definitely be improving on this.
Okay, thank you very much, and another round of applause to Zbyszko.